we will start the second part of the unit and dimension. That means whenever we want to find the dimensional formula of any unknown quantity, already I have shown, but suppose we want to find the dimensional formula of any physical quantity from any formula. So how to find? For example, suppose the gravitational formula of Sir Isaac Newton. What is the gravitational formula for Sir Isaac Newton? F equal to G m1 into m2 by r square. So suppose from this formula we have to find the dimensional formula of G. So how to find? So make first G as a subject. That is G equal to f r square by m1 into m2. Now directly put the dimensional unit or formula of force. R means distance, m1 and m2 that is mass. So what we get? We get this one. So ultimately the answer will be so it is the dimensional formula of G. But suppose it is not with the MLT system. It is not with the MLT system because we know from SI Standard International System of Units that there are total 7 plus additional to 9 fundamental units. Suppose I am showing you another one. It is also made by Newton. The conduction law, heat conduction law. Okay. So heat conduction law by Newton. So what is that law? See. This law states that the rate of flow of heat, that is Q by T. I am taking that Q is the heat energy equal to this one. This K is the thermal conductivity, A is the area, T1 minus T2 means temperature at the hot end and the cold end. That means high temperature and low temperature at both the ends, and X is the length of the conductor. Q is the heat energy and small t is the time. So from here, if we want to find the dimensional formula of K, so find K. That means the dimensional formula of K. So how I find? See. Make K as a subject. So K equal to Q, X will be up, T down, A down, T1 minus T2 down. So this. Now what is the dimensional formula of Q? That is heat energy. Heat energy or any type of energy, not only heat energy. It may be sound energy, light energy, electric energy. Energy dimensions are all same. So what is that? ml square t to the power minus 2. So put the value ml square t to the power minus 2. X is the length, so L. Then T is time, A is area, and it is temperature. Now, temperature is also a fundamental quantity according to SI. And what dimensionally we write what? We write is either K because it comes from Kelvin or theta. So see here already one K is there. So it is confusing. So to avoid the ambiguity, we are using theta. theta for temperature. So what we are getting the answer? Very easy. We are getting m L T to the power minus 3 theta to the power minus 1. Correct? So this is the dimensional formula of K. And what is K? Thermal conductivity. This is the thermal conductivity. So this much we told that MLT system, and also one new one, that is the temperature theta. But according to SI, more physical quantities are fundamental, not 3, not 4, more. So let us do some example that is present in electricity. I am doing one famous law in electricity that all of you know, that is the Ohm's law. So what is Ohm's law of electricity? V equal to IR, that is the main fundamental law of current electricity. So let us find the dimension of resistance R. Just dimension of R. So it is example number 3. So V equal to IR, therefore R equal to V by I. Correct? Now the question is that what is the formula of V? What is the formula of V? V means what? Potential. So potential V equal to W by Q, where W is the work done and Q is the charge. Actually, potential is defined as work done per unit charge. So let us put the dimension of work done and charge. But what is the dimension of charge? Wait. Again, I equal to Q by T, because we know that current is the rate of flow of charge. So if current is the rate of flow of charge, then very easy to understand, I equal to Q by T. Therefore, what is Q? Q equal to IT. Now, according to SI, I has a dimension. So, what I write I in dimensional form, like MLT, K or theta, we write I as A, because unit is ampere. Sometimes it is also written as I also, no problem. So, write as A and time as Q. So, dimensional formula of Q is 8. Now put the value here. Work done means M L square into the power minus 2 by 80. So potential we are getting what? M L square e to the power minus 3 a to the power minus 1. So that is the dimensional formula of potential. Now current I already we know I is A. Therefore, dimensional formula of resistance will be, just put the value M L square e to the power minus 3 a to the power minus 1 by A, because current. So what we are getting? This one. It is the dimensional formula of resistance. Now, up to this we have seen that different dimensional formula, not only MLT, beyond MLT, the temperature, the current. Now, actually, this dimensional analysis is also used to find the formula, to find the physical formula. That means, suppose we know that force equal to mass times acceleration from Newton's second law, F equal to m. Now, can we prove this formula without doing the actual derivation? That means without the Newton's second law definition, the actual derivation. Can you prove that F equal to ma, that it is dimensionally correct? Now, if I want to prove, then what I do that F one side and LHS and MA one side. Put the dimension of F at LHS because it is MA to the power minus 2. Now then M into A it will come. But we know that if equal to MA, then we can check, verify. But suppose does not know, anyone does not know that F equal to MA. And only information he or she has, that force depends on mass and force depends on acceleration. Then how that person can prove F equal to M? So this method is known as principle of homogeneity. That is, using dimensional analysis, we can find any formula. But there is one drawback. There is one drawback of this method, that if any constant, maybe 1, 2, 3, 4, maybe pi, that is 22 by 7 or 3.14. Any constant value we can't find using this dimensional analysis. The constant value can only be found out using the actual derivation. Actual derivation using the law. Okay. So let us see how we can find the formula, though it is without constant, but we can find the formula at least using dimensional analysis. Let us start. So this process is known as principle of homogeneity. Let us see. So it is our principle of homogeneity. Now we will start the error analysis, that is the second part of this unit and measurement chapter. Now error analysis means what? Error analysis means that whenever we are measuring any physical quantity, there are some error. The error may be human error, the error may be instrumental error. So to avoid the error, there are several techniques. Number one technique is we have to take the mean value of multiple readings. We have to take the mean value of multiple readings to minimize the error. This is one technique. Another technique is the graphical technique. Suppose we know the variation of that physical quantity, the nature of the graph. It may be linear, it may be non-linear. Now non-linear different category, sometimes parabolic, sometimes exponential, sometimes hyperbolic, sometimes circular. So with that nature of the graph, we can also find the error or minimize the error. Now the question is, the first category, the first type, that is taking the average. How to take the average? I am discussing the first one, how to take the average. Suppose you are taking the reading of any physical quantity multiple times. So first time the reading is suppose x1, second time x2, and in this way nth time it is xn. Now take the average of that all. Okay, like this. Just see. So it is the error analysis. So suppose first reading is x1, second reading x2, and in this way nth reading is xn. Therefore average value is summation of x by n, which is our x app. Okay. Which is our x app. Now we find the deviation. Now we find the deviation of each reading with this average value. What is the deviation? But deviation may be positive. That means x1 maybe more than x average, maybe less than, maybe positive, maybe negative. So in that case, we have to take the mod value. So just see, therefore, in first case, the deviation, take it as delta x1 is x1 minus x average, mod value of that. Second case, the deviation is delta x2, that is x2 minus x average. Similar way, nth case, nth, delta xn equal to xn minus x average. Correct? Now we take the mean value of all the deviation. So what is delta x mean? This one. So it will be summation of xi minus xab by n, where I varies from 1 to n. I varies from 1 to n. So it is the formula of. Now this particular quantity is known as, this delta x bar is known as absolute error. Absolute error. Okay. So this is absolute error, and after that it comes the proportional error and the percentage. So what is proportional error? Proportional error is just the ratio of this absolute value to the average value. So it is our proportional error. And what is percentage error? Percentage error is this proportional error into 100. So delta x bar by x average into 100. So in this way we can find the proportional error, percentage error as well as absolute error also. So it is the way to finding the error by means of average, taking the average. Now after that there are combination of error or propagation of error. Suppose there are two physical quantities. We are adding that, we are subtracting that, we are multiplying that, we are dividing that. So in that case, what will be the net error during addition, subtraction, product or multiplication and division? So what is the resultant error? How I find this? So it is known as combination of error, or you can tell propagation of error. So it is combination or propagation of error. So first I go for addition. Number 1. Now in this case, let two physical quantities are A. So in the first quantity or first value, suppose A plus minus delta A. So this delta A is actually the average value. Delta A is the average value. And the second value is suppose B plus minus delta B. That is the average value or absolute error. So delta A and delta B is the absolute error, and AB is the actually average. This is the average value of deviation. So this is the absolute error. So this one is the error. For A, this one is the error. For B. So now let C equal to A plus B. So how I can write then error of C? Therefore, C plus minus delta C equal to A plus B, taking plus minus common, delta A plus delta B. That is, finally we are getting delta C equal to delta A plus delta B. So it is clear that error is always additive. Error is always additive relation. Now go for subtraction. For subtraction the same thing, only we take the difference. That means here let C equal to A minus B. So in the same way, we write C plus delta plus minus delta C equal to A minus B plus minus delta A plus delta B. Again, delta C equal to delta A plus delta B. Again, this value will come because it is never negative. It is always additive. Additive relation. Additive relation. So, it is the addition and subtraction. Now go for multiplication. Now go for multiplication. Additive relation. Now go for multiplication. So going for multiplication. Just see. If I take the product, that is multiplication. Number 3. Then what will happen? Just see. Let C equal to A into B. Therefore, C plus minus delta C will be A plus minus delta A into B plus minus delta B. But again, if I multiply this, we are getting A B plus minus A delta B plus minus B delta A, then again plus minus delta A delta B. But this delta A delta B is negligibly small. But this one is negligibly small. That is less than 1. Therefore, we are getting AB plus minus A delta B plus minus B delta A. So take AB common. So 1 plus minus delta B by B plus minus delta A by A. Take plus minus common. So AB 1 plus minus delta A by A plus delta B by B. Okay. So here also take C common. So 1 plus minus delta C by C. So ultimately we are getting that delta C by C is equal to delta A by A plus delta B by B. So this is the rule of product. This is the rule of product. Now I go for division. Okay. So let's go for division. So product or multiplication rule 2. Now in case of division, just see. Number 4, the division. So the rule is same, only this will be let C equal to A by B. Therefore, C plus minus delta C will be equal to A plus minus delta A by B plus minus delta B. So take from here A common and from here B common. So A 1 plus minus delta A by A by B 1 plus minus delta B by B. Okay. Now from here I can write A by B 1 plus minus delta A by A and then 1 plus minus delta b by b to the power minus 1. So here also it takes c from. So 1 plus minus delta c by c. Okay. So this one. Now if I do this, then by binomial approximation, we get that 1 plus minus delta b by b to the power minus 1 will be 1 minus plus delta b by b. This will come. So ultimately, again the same rule, c 1 plus minus delta c by c. It is by what? It is by binomial approximation, or simply binomial. So ultimately, a by b, it will be 1 plus minus delta a by a plus delta b by b, again neglecting that delta a delta b, neglecting that one. Okay. So ultimately the same result we are getting, that is c delta c by c equal to delta a by a plus delta b by b. So this is the division. Okay. So this is the propagation of it. Okay.